simple structure. Okay, we start on the Truss. So you go to your software. Okay, you open the software. Okay, so this is the interface, and this is the template. Actually, we can see this is Truss 2 design, frame 3 design, frame 2 design, and so on. And you can choose either new or open project. Okay, so if you have a previous project that you want to proceed or continue from the past, so you can just open your project and choose which folder or which file that you want to continue your work. And you can either choose new, or better for you if you know that you want to do the Truss, so you just select the Truss. Okay, so this is the interface once you open the robot. Okay, I think I no need to explain in brief on this menu toolbar and the shortcut tools here, because I already shared to you the video on the introductions of Autodesk Robot, so you can view the video. So I will just straight away to our tutorial. So you have here the following figure shows a steel truss with equal span of 4 meter and the height is 3 meter. The concentrated loads are applied at the truss node with 3 different load cases as shown. Okay, so this is the sections of your truss. Okay, you have to use these sections and you need to create your model. And this is your truss. Consists of how many span? 1, 2, 3, and each have 4 meter length and applied by dead load, live load, and also wind load. So we go back to our robot. So this is your by default your grid line, and your shortcut tools bar here is actually can be viewed from here, geometry. Okay, it's the same. Okay, from this geometry and also this shortcut tools bar. And the flow of this icon is following our flow to create the models and proceeds with your analysis. Okay, so here you can start. The grid step is not necessary. It's actually want to define your by default grid. Okay, by default your grid step is 2. So maybe if you want to directly draw your member, you can see there is an odd number distance here 3. So it's hard for you to click the member later on. So maybe you can put it as 1, but it's not necessary actually. Okay. So you apply, you can see, better you use your mouse, okay? And you can play around with your cursor up and down to zoom in and also zoom out, so it changes to one scale, okay? 1.0 scale. And it can be used if you want to directly draw your member. Okay, but I refuse to do this method. Okay, because it's not very practical to do. Okay, anything. Okay, so instead of that, you start with exist definitions. Okay, because for exist definitions, you can create your own dummy exist based on the given dimension here. Okay, so since we choose 2D plane, okay, so for robot, our 2D is on exact plane, not XY, okay, so exact plane. So we have X direction and Z directions. So in our X directions, we have distance 4 meter. Okay, from 0, the distance 4 meter, and we need to repeat 3 times. Am I right? 1, 2, 3. Okay, we need to repeat 3 times. You add here. Okay, so you can see we have 1, 2, 3, 4 nodes. Okay, so not 1, not 2, not 3, not 4. And then you need to add. Okay, already add. Okay, and this is numbering system by default. And then next we go to Z, start with 0, and our distance is 3. Only repeat once and we add here, And you can change your numbering instead of 1, 2, 3. Just now we use for x-axis. So for z-axis, we use A, B, C. Apply here. Okay, so you can see this is what you view. The new grid line that you define for you to assist in drawing your member. Okay, next we draw a member. So from its definition, there will be a note, but we just keep this process because once you draw your member, it will automatically also define your note. Okay, and how to draw your note, your member actually, it's based on the directions. Okay, if you have a questions, if I have time, maybe I can go through it. Okay, if the direction to the right, so you need to follow the order from 0 to the right and the next and next. Okay, because the numbering system is there. Okay, so here this is your member. You can just put your cursor at the intersections of your grid line. Start from here and then next is here. Okay, so this is one member. How you want to know this is your member? You can see at the bottom here. Please click note number and also member number. So this is actually a numbering system as what you learn in stiffness method. Okay, so this is note number 1. Note number 2 consists of member 1. And what happens if you drag here? Okay, so it will continue. You can draw continuously from note 2 to note 3, note 4, 5, 6, 7, 8, 8, 9, and because you still have clicked the drag, so it still follow. Okay, next here, next here. Okay, and then next you want to draw the member from 6 to 3. Okay, so you cannot go to 6 because you will I think you will duplicate member number 12. So you need to press escape. Okay, so clean, there is no member, so you need to go back to 6 and go to 3. Okay, so close. So this will be your note numbering and also member numbering. And then after that, we go to a member section. Okay, so before we go to member section, because this is what the sections that I have already defined based on my database. Okay, you can also call the new member, but what I skip is here. We need to go to the tools first. Reference is just language parameter. There is okay. Make sure Eurocode and English. Okay, no need to change anything. Okay, this is important. Go to job preference. Is your units here. Okay, make sure you can change the units based on the project that you handle. Either they want to use meter, centimeter, and so on based on the dimensions. And this refers to decimal places. If you go to right arrow, so it will increase to 3 decimal, left reduce to another 2, and go to force. By default is kilometer. I won't just maintain this. But for this placement, instead of centimeter, I prefer millimeter and go for 2 decimal places. And then unit addition materials, we reference to Eurocode. Okay, for materials, we referring to Eurocode. We will use steel. Also mention mild steel, so this consider mild steel. But for the database, okay, we have several types here, but our syllabus only focus this steel and timber sections. Instead of Eurocode, I prefer we change into UK standard, okay, because our industry, I think, more familiar using UK standard for the material section, okay. So make sure your arrow is at UK standard section. Okay. Okay, so then you can go here and define your section. Okay, your questions. What is your sections? We have, so this is the angle. Okay, section equal angle 70 times 70 times 6. Okay, so this is the level for the section. So add here. And another section is, okay, once you add, you can see it will appear here. Okay, and another section is EA 50 times 50 times 6. Also equal angle 50 times 6. Okay, you add here. Okay, so this is to the new angle. Close. Okay, so we go at this first. Okay, make sure your arrow here. So go, next you want to define your member section. Okay, so go to here and you can select your member. 7 and apply. And how if you want to select multi-member? So go to 6, make sure you press Ctrl, go to 5, go to 3, 2, 1, and click apply. Okay, so next is for our internal, our verticals and diagonal member. Okay, you actually also can just select like this. Okay, if you select from right to left, it will highlight the member that touch your rectangle. But if you select from left to right, okay, it will only highlight the member that inside the rectangle shape. Okay, so again we need to highlight from right to left. Okay, click apply. Close. Okay, finish. For this we go to materials. No need to do for materials, we just follow by default the materials, and we go to